All right, so today we're doing section 5.3, which is called dividing rational expressions. Also, it has complex fractions. Those are the last two problems we're going to do is complex fractions. Don't make it, don't worry about it. If it doesn't get more difficult, same thing. It just looks weird, but it's the same thing that we're going to be doing right now. Okay? But they're called complex fractions because it's a fraction divided by a fraction. Okay, so it's going to look like a really big fraction, right? A fraction on top, a fraction on the bottom of a fraction. So they call them complex fractions. Now, in the very beginning here, we do have a quick reminder of the way things works. Okay, so if I were to ask you to multiply 2/3 times 5/10, okay, 2/3 times 5/10. What I would be doing in the very first part was I would get my 2 and my 10. I see that I can actually reduce those, or the 5 and the 10. I can reduce those, right? So what I'm going to do is let me go 5 and 10. I always prefer going vertically if I have an option. So I'll go vertical first. This will become a 1. This will become a 2, right? 5 over 10 is a half. So this is 2/3 times 1/2. And now I notice that diagonally, I have 2's that match. So this will cancel with that. So I get 1/3 times 1 over 1, which is 1/3. Okay? And that's it. I'm done. Okay, this is how it works with numbers, right? No big deal. We've been doing that already. Um, but all we're basically doing is trying to get this thing simplified and multiplied. Okay? So with the second part, notice everything is the same except for instead of multiplication, it's division, right? So what you have to do first is you have to rewrite it. So you're going to write 2/3 times 10/5. You always multiply by the reciprocal. You're not going to divide by a fraction. You're going to multiply by its reciprocal. At that point, try to simplify as much as you can. So 10 over 5 becomes 2 over 1. Okay? So this would be 2/3 times 2 over 1. Unfortunately, remember I told you guys I bet you I'm going to find people that cancel side to side? It happened during the quiz yesterday, not just once, but many times, right? I told you guys do not cancel out sideways. You can go diagonally, you can go vertically, but never side to side. So unfortunately, a lot of people did this yesterday and ended up getting things wrong. But we can't do that, right? I can't reduce 2 over 1. I can't cancel out a 2 and a 3, right? I can't cancel out sideways. So this basically is just 4 over 3, and I'm done. Okay? So remember, if you're just multiplying fractions, simplify as much as possible, but you multiply straight across, right? If you're dividing fractions, then change the division to a multiplication, and the second fraction gets flipped. Okay? The second fraction gets flipped. And then just simplify it by multiplying out, canceling things out, and you're going to be fine. Now, this is all great, but we're doing stuff like this, right? We're dealing with letters as well. And we're starting off with some easier stuff as usual, right? And then we'll get to the more difficult stuff. Um, but we're going to do 6 different examples. 4 are going to be these fraction type problems, and the last 2 are complex fractions. Okay? So this one right here, I have 3r over 10 divided by 5r over 4. So the very first thing I'm going to do is rewrite 3r over 10 times 4 over 5r. Okay, now notice I can cancel out the r's right away. Okay, the r's are diagonal to each other. I can get rid of those. Those are gone. What else can I simplify? The 10 and the 4, right? 4 by 2. I can divide those by 2. So if I get 4 divided by 2, it's 2. 10 divided by 2, that's 5. So here's my result from getting some of these things out of the way. Now remember, you cannot cancel 5 with 5. No sideways cancellation. Okay, you can go diagonal, vertical, but not sideways. So that means that nothing else can be reduced. So let me just multiply. 3 times 2, that's 6 over 25. Okay, and that's it. Again, this is some of the easier stuff, right? They always give some easy problems, and then some medium difficulty, and then some harder ones. So we're doing like the easier stuff right now. But we'll move on from that. But this is how they expect you to do it. Now notice, this right here, this part now, if you ignore all the cancellation, but that part right there that I circled is the only thing that's new. Everything else that I did after that is what we did in section 5.2. So nothing is new except for the time and the flip fraction. Okay? That's the only thing that's new. Everything else is identical to section 5.2. So section 5.3 shouldn't be like, oh my gosh, I was totally good at 5.2, but I suck at 5.3. They're the same problem. It's just you got to put time and flip a fraction. Okay? So here's another one. Now I know this one looks a little bit more difficult, but remember what I told you guys, these are pre-factored for you guys. That means that they're easier. They're pre-factored. Okay? So they want us to simplify some fractions. 3 times p plus 5 divided by 3 divided by 56p times p plus 1 divided by 7 times p plus 1. Now I know there's a lot of stuff you might want to cancel out, but just wait on the cancellation stuff. Okay? Because sometimes if you cancel too early, you might do it wrong. So for these problems, fix it first, meaning change the division to a multiplication, flip the second fraction. So in other words, make it look like 3 times p plus 5 over 3 times 7 times p plus 1 over 56p times p plus 1. And now start canceling stuff out. So on the first fraction, I know I can get rid of the 3. On the second fraction, I can get rid of the p plus 1. Okay? There's one more thing you can kind of do, but let me wait. Let me rewrite. Just so it doesn't get too busy with too many marks. This is p plus 5 over 1 times 7 over 56. Unfortunately, yesterday I also saw this. I saw people do a little bit of this. Remember, and I told you guys you cannot cancel inside of a binomial unless you got a matching binomial, right? But people were still doing it. I don't know if it's just that you forget or maybe you just don't hear me. I'm not sure. But again, that is the rule. You cannot cancel one piece from a binomial with one other piece somewhere else. You got to get rid of all of them. So if I want to get rid of p plus 5, there better be a matching p plus 5 somewhere else. And it can't be side to side. It's got to be either above and below or diagonal, right? What else can I reduce this? There's one more thing. And I just told you, it's not the p. 7 is 56, right? 7 times what is 56? 8. So that means I can reduce the 7 to a 1 that's 56 into an 8. All right, so at this point, I have p plus 5 over 1 times 1 over 8p. And that's it. That's all I can do. So let me just multiply across. Some of you guys left your answers like that yesterday. I mean, I guess essentially I could have marked it wrong because it wasn't totally multiplied, but I just said fine. It's okay. You did as much as you could. It is correct. It's just not together, right? We want to make sure we put it together. So you'll notice for some of your answers, I gave you credit if you left them separated sometimes. Even if you didn't simplify everything 100%, I'm still giving you credit for it. It's not that you're wrong, you're just not all the way correct. Okay? And I don't want to punish you for like not taking the 2 over 4 and writing 1 over 2. Like you did everything else right. I don't want to punish that. So you'll see that. I might put like, you'll notice I'll put something like this. Okay. Next to your answer. That means it's close enough. Okay. It's not where I want it, but it's good enough. That means you maybe didn't reduce. Maybe you can multiply something together. But if you see an okay, that means like good enough. Good enough to be correct. Okay. but not the answer you should have. So, close. A check mark obviously means close. All right, so we're moving on. This one right here is not pre-factored for us. It might look like it is because there's a little parenthesis on one side. And it doesn't look like it's too busy, but it's definitely not pre-factored for us. I am going to write over 1 on the right side. That way I know it's a fraction, right? And remember, we're dividing by a fraction, so we want to put multiplied by the reciprocal, right? So my very first step is to rewrite this 56x equals 56x plus 64 over 7x plus 8 times 1 over 2x minus 6. Now, yesterday, unfortunately, I did see people canceling x with x, 56 and 7, they put 1 and 8, right? You can't do that, right? These are binomials. They're stuck together like glue. You can't just take them apart piece by piece, right? There was a lot of things that came out wrong because just little nitpicking like that. I told you guys, don't nitpick. You gotta take a chunk or maybe a tiny, right? But nothing away from the binomial. So, all right, 56x plus 64. I can take out an 8 from that. Okay, I can factor an 8. I'm not canceling anything yet. I'm trying to factor things out. So this will leave me with 7x plus 8. Now, if you notice the bottom, that matches the top, right? So I'm just going to leave it 7x plus 8 because I can't factor it. It's not a trinomial. It's not a difference of two squares, the bottom part, 7x plus 8. And it has no GCF. So I just leave it like that. Times 1 over 2x minus 6. I can take out a 2. So 2 times x minus 3. All right. I can cancel out 7x plus 8. Right? What else can I do? There's one more thing I can do. The 8 and the 2. 2 goes into itself 1, into 8 4 times. So let me rewrite. There's going to be 4 over 1 times 1 over x minus 3. Again, I hope you don't leave your answer like that, but if you do, I'm okay with it. You should multiply together. So 4 times 1 on top, that's 4. And 1 times x minus 3 is just x minus 3. And there you go. Fix that right there. So you guys see how this is basically the previous lesson, right? It's just one step, and we got to put time in the step, right? After that, it's the same thing. So if you were good at 5-2, then you should be good at 5-3. Just time flip and do what you used to do. Remember, we got 6 examples. This is the last one of these. I think it is. Yeah, it's the last one of these. And then look, this is a complex fraction, so a fraction over a fraction is an easy one. And then here's another one, fraction over a fraction. Also not terrible, but here's our last one of the tough. Okay. So I'm gonna rewrite this first. Okay. So let me correct color here. So there's gonna be x squared plus 7x plus 10 over 4 minus x squared times that's x squared minus x minus 72 over x minus. And remember, with these tough ones, I used to do them in like sections, right? So I'm going to start with the left side fraction top part, okay? The x squared plus 7x plus 10. I know a is 1, b is 7, c is 10. So according to my x method, it's 10 on top and 7 on the bottom. Okay? Two numbers that multiply to 10 that add 7 would be a positive 5 and a positive 2. And you're supposed to divide by a, but a is 1, I don't need to. So these are good answers. So x plus 5, x plus, I'm going to put that right here, x plus 5, x plus 2, divided by. Okay. Is the next one, green right here, okay. This next one, 4 minus x squared. It's not a trinomial, so not an x method. So, sorry, not a, not an x method. Okay. It's a binomial. Is it a difference of two squares? Well, is it a difference? Yeah, there's a minus. Is the variable squared? Yeah, x squared. So can I try it? Let's try it. Something squared minus something squared. Okay. Well, what squared is 4? It's 2. And what squared is x squared? An x. Now I know this looks weird because we normally are used to the letter in the front, right? Not the number. But we still do it the same way. 2 minus x, 2 plus x. Okay? So I'm going to put 2 minus x, 2 plus x times. All right, next one. The next one is the x squared minus x minus 72. The right side fraction top part. So x squared minus x minus 72. A is 1, B is negative 1, C is negative 7. Right? So according to my x method, on top I put minus 72. On the bottom I put negative 1. Two numbers that multiply to a negative 72 that add up to a negative 1 would be a negative 9 and a positive 8. Negative 9 plus 8 is negative 1. Negative 9 times 8 is negative 72. I'm supposed to divide these by 1, which some people did forget yesterday in the quiz to divide. I think there was problems where you divided by the 2 or 3. And forgot to do that. So unfortunately, there was some wrong. Not too many. This would be x minus 9, x plus 8. And we put that right here. X minus 9, x plus 8. And then the last one, thankfully, is pretty simple. It's just an x minus 2. Okay? So if you don't mind, I'm just going to do it right here. X minus 2. It isn't a trinomial, so no x method. It's not a difference of two squares, because even though it is a difference, it's subtraction, x is not squared. And it has no GCF. So basically, I'm just going to put a parenthesis around it. Okay? So here we go. Now you see all these that are on the bottom left, the green ones. You see how they're backwards? We normally like the variable in the front and um, and the number in the back, but it says 2 minus x, 2 plus x. Let me flip it. Okay, I'm going to take a little extra step if you guys don't mind. I'm going to flip it. So I'm going to leave it x plus 5, x plus 2 over. If I take 2 minus x and flip it to x minus 2, what am I supposed to do in front? You guys remember? Because addition, I can just flip, no problem. Flip it. Okay. But if it's subtraction, I can flip it, but I'm supposed to do something special in the front. Change the sign. Should be minus. Okay? Now the 2 plus x, that's x plus 2, but remember, addition is commutative. That means I can move it back and forth. So I don't have to change signs on that one. Times x minus 9, x plus 8 over x minus. All right, now let's go ahead and start chopping things up. So x plus 2, gone. Anything else that I can get rid of? Vertically, diagonally, not horizontal. Because I know people might say, well, let's find 2 on the bottom. Yeah, but can't cancel that. Are we good? We're good, right? So here's my final answer. It's going to be kind of long, but that's okay. I see a negative on the bottom, so I'm going to put it in the front, okay? X plus 5, x minus 9, x plus 8 over. Now, if you want to write x minus 2, x minus 2, feel free, I'll do that. Or you can write x minus 2 quantity squared. But this would be my answer. We did as much as we could. We canceled out as much as we could. And that's just what my answer. Don't multiply it out. Leave it like that. Back this one. Best. Are we okay with this one? Like, these are probably the tougher ones because they're the biggest ones. But why did I flip the first fraction? Oh man, why did I flip the first fraction? I shouldn't have done it. That's a good catch. You guys not see that? I know somebody did it. Did you see it early? You should have told me that. All right, let me fix it. I just did this. I don't know why I flipped it. Now it's all the factoring is done right, so that's a good thing. But I should have not flipped the first one. I don't know why. So let me do this. I'm gonna correct it. Just put an X around it. Sorry about that. But I'm gonna actually try to keep some old information there for me. So let me do that. All right, hold on 1 second. Let me keep this. This should still be. I remember, if I make a mistake, tell me right away. Because or else we spent all this time. All right. So the reason why I kept this is because it's going to help me remember what's back. This part right here, I'm going to leave it alone, okay? I'm not going to change anything. Those factors are still the same. But this part right here, I'm just going to flip it, okay? I'm going to flip this part on the bottom. So, sorry about that. This is going to be, what did I use for that? Green. Go to green. This should be 2 minus x, 2 plus x over. That was for the green part, and then the other one I used red. All right. And this is going to be x plus 5, x plus 2. And then the next step I told you, if you guys don't mind, I'm going to flip some stuff. So I did that. So I flipped the 2 minus x, so negative x minus 2. I flipped the other one as well, but I didn't have to put a negative in front of that one. And right now, I'll go through and explain it again. Sorry about that. I didn't notice I flipped the first fraction. I did notice I flipped the second one. And our answer obviously is going to be. All right. So if I may, you're not supposed to flip the first fraction. That was my bad. Okay. Only remember I said it's only times flipping the second. Times flipping the second. I even circled it earlier, right? To say it's only this part. For some reason my brain said do both. Why not? Right? So we're gonna leave the first fraction, the 4 minus x squared over 7, over x squared plus 7x plus 10. We're gonna leave it alone, and then make it times the flip portion. Okay, so we flip it. Once we flip it, we factor everything. So thankfully, everything factors the same way. It doesn't matter. Okay, so the 4 minus x squared becomes 2 minus x, 2 plus x. The x squared plus 7x plus 10 becomes x plus 5x plus 2. So this basically is factored the same way. Then the second part, the x squared minus x minus 72 still becomes x minus 9x plus 8. And then the x minus 2 is still just x minus 2. Okay, so all that, we already did all the work on the side, so I didn't have to, thankfully, I don't have to redo everything, right? Just rewrite. Once I did that, I am still going to flip the stuff in green, the 2 minus x, 2 plus x. I'm going to flip it because I got to get it to cancel stuff. Okay? So I flip the 2 minus x, so it becomes negative of x minus 2, right? And then the 2 plus x, I wrote it as x plus 2. Everything else did exactly the same. Now we cancel, and I'm hoping my answer comes out a lot smaller. Let's see. The x plus 2 will cancel with the x plus 2. The x minus 2 will cancel with the x minus 2. And that's it. So my answer will come out to, let me put right here, negative 1 over x plus 5 times x minus 9x plus 8 over 1. And I'll just combine it. So negative x minus 9 x plus 8 over x plus 5. Remember, you can put the negative on top or on bottom. I prefer in the middle. And this would be my answer. Thank you for the question. I knew when I wrote my answer, it just looked way too busy. But I looked at my work and I'm like, my work looks good. My factors look good. Maybe it is just a really busy answer. And then when you said you flipped the first one, I'm like, that would make sense. I'm like, that would totally make sense. Because usually you cancel a lot more stuff in one thing. So thank you for that. Now I'll make sure to give you extra credit for that. So are we good with this one after the rewrite? Okay. All right. So last two things, and these might look like they'll take a long time, but they don't. Okay. As long as I don't mess up, it shouldn't take much longer. The main thing you have to do with these is rewrite them horizontally. Don't leave them vertical the way they are. Okay. Rewrite them horizontally. In other words, 4/5 divided by 1/3. Do that. Just kind of read it out loud, right? I see 4/5 divided by 1/3, so I'm going to write 4/5 divided by 1/3. Now, we don't divide fractions, we multiply by the reciprocal. So, 4/5 times 3 over 1. And then you simplify as much as you can, but I can't, right? None of these numbers work together. So I'm just going to write 12 over 5. And that's it. This is a complex fraction. You know, it sounds more complex than that, but that's a complex fraction. Now, sometimes they'll give you things with expressions, okay? Thankfully, not too complicated. This is the last one, by the way. So, again, write it out the way you read it. I see x plus 2 over 3x plus 2 divided by x, x plus 2 over x minus 3. And then I'm going to rewrite it as the multiplication of the reciprocal. So this is going to be x plus 2 over 3x plus 2 times x minus 3 over x plus 2. And then I have to ask myself, can any of these things be factored? But if you look, x plus 2 cannot be factored. There's no GCF, there's no difference in 2 squared. On the bottom left side, 3x plus 2 cannot be factored either. It's not a difference of 2 squares, there's no GCF. On the top right side, x minus 3 cannot be factored either. No GCF, no difference of 2 squares. And then the other x plus 2, well, we already talked about it, you can't. So this is as simplified as you get. I'm just going to put parentheses around them. And then after that, chop them up. So this is gone, that's gone. And I'm done. Basically put it together. And I'm finished. So this is going to be 1 over 3x plus 2. By the way, this is the step that you don't have to do if you don't want to. Combine in your head, it's fine. All right, and my answer is going to be x minus 3 over 3x plus 2. So there you go. My apologies, I messed up on number 4. Okay, and thank you for that.